Hey, good morning, everybody. Today's lesson is going to focus on how to find the area of composite figures. Those are shapes where one shape is kind of put into another, and they might be just both rectangles or a rectangle and a triangle, a combination of things like a triangle trapezoid with a rectangle on the end and other things. But it's basically composed, that's why it's called composite. It's composed of different shapes put together. Okay, I'm going to walk you guys through a few of these examples here. And for this first one right here, this one's a pretty straightforward example where you have two rectangles that look like they're kind of put together. And, at first glance, you might look at this and you see this small rectangle on top, and you have this larger one, of course, on the bottom. So there's couple different ways you guys can do that. So you can just take the smaller area right there. Now you're just going to, when you find the area of that smaller rectangle, you're just going to do length times width, or another way to put that is base times height. So you can just do 6 times 3 or 3 times 6, doesn't matter. But that's 18 square inches right there. And then right here, this larger rectangle, it's pretty straightforward. That's a 9 by 7. This is 7, and that's 9. And that's 63 square inches right there, 63 square inches. So make sure when you do these problems that you add up the areas that you just got. So we got 18 for the smaller area plus 63 for the larger area, and then put that together, and what do you get? You get 81. And now make sure you put 81 square inches. That's the total area of that composite shape. You know, if we call this area A and we call this the area of B, well, A plus B was 81. That was it, 81 square inches. Now, just to kind of make a point here, let me just show you, there's, you might have looked at that problem and you said, I didn't see it that way. I totally saw, when I was looking at this, I saw this really tall rectangle here. And then maybe you saw like the shorter, but a little bit wider rectangle there. So maybe we'll call that A and we'll call that B. But it shouldn't matter how you look at it. As long as you find the areas in the right way, you're going to be fine. You can get these correct either way. So we're going to find let's find the length and the width of A. Now this is right here, that's 4. Now how do I know that's 4? Well, it says it's 4 up here, right? So this and this, it doesn't matter that you looked at it that way, but that's 4 and that's 9. So the area of A is going to equal 36 square inches. And then the area of B is going to be a matter of, again, finding the length and the width there. This is 3. And how do we know that that's 3? Well, this is 3 up here. Look up. Look around when you're doing these shapes. Look around the shape. Sometimes you're not going to see numbers exactly where you want them to be. Maybe you're looking for some number. Well, if this number right here, if this length right here, I should say, that length that I just kind of outlined right there, if that length is no different than that length, I'm talking about the segments, then they're going to be the same. They're going to be the same measurement at least. That's going to be 3. So that's going to be 3, and we're going to multiply that by 15. So 3 times 15 is 45. And just like we did on the other one, the previous problem, where it's the same problem really, but we had different areas. But we have 36 plus 45, which again, when you add that up, 36 plus 45, guess what that equals? That equals 81 square inches. So you get, no matter how you do it, you're going to get that. Now let me be a little bit annoying here for you. Just to show you one more way. Again, I want to make sure I kind of touch all the bases. Now, I'm not expecting you when you guys do these problems to show me all the different ways you guys can figure out the areas. I am going to at least do it on this one. And A third way to see this is, maybe you looked at this as, at one point it was one complete large rectangle, one big parallelogram essentially, one big rectangle, and someone came along and then cut a part out of it, with some scissors. Cut this piece out, right out of there. So what I'm talking about with this one right here in particular, I'm talking about like this right here. You might want to think of that as negative space. It takes away from the area of the larger rectangle. So what you could do is you could find the large rectangle area, and write that down. Well, the large rectangle is going to be 7 by 15, which is 105 square inches. And then you can find the negative space, the smaller rectangle. And you're going to do 6 times 4, that's 24. So then where do you go from there? Well, like I said, we're talking about the negative space. That's a negative area in a sense. It's an area that is being removed from the actual area of the larger rectangle. So what we're going to do is we're going to take the larger rectangle and we're going to subtract the smaller rectangle. 105 minus 24, and I bet you can guess what this is going to equal. It's going to equal 81 again, just like we've done on the previous 2 iterations of this problem. We've got 81 square inches for the area. So I know that was a little bit annoying for me to go over all the different ways of finding area, but I think it doesn't hurt to kind of talk about, what are all the different ways? You might see this differently than someone else. You might be talking about, well, how did you do this problem? And they might have a completely different way, but you both arrived at the same answer. And the most important part is that you guys both got the same answer. That's the most important thing. So it's okay whether you look at it as maybe a tall rectangle and a not so tall one, or maybe you see a large rectangle and a small rectangle, or you see a negative space. It doesn't matter one bit. Like I said, what's important is that we all ended up at the same conclusion there of getting 81 square inches. All right, on number 2, there's a lot going on that problem. Like on the first one, I definitely saw a lot of different ways we could have done that. And what I would suggest doing, my advice to you, is to kind of break it up into as few shapes as possible, so that when you do this, I think the more shapes you end up making it into, the more likely you are for error. There's more likelihood for a mistake. So if you could break it up into as few parts as possible, I think that's going to be to your benefit. All right, so maybe some of you see this, and maybe you don't, but maybe you see a triangle right here. So we have that triangle. And sometimes you'll notice, like, I like to label things, like I'm going to call this triangle A. It doesn't hurt to be organized here with your information and how you set it all up. You might also see a rectangle right here. I'm going to call that B, call that shape B, that's right there. And then at the very bottom right here, what shape is that? That is a trapezoid, right? I know it doesn't look like your typical trapezoid, but it has 2 parallel sides, right? And the other segments are not parallel with each other. So that's all that you need for a trapezoid. Now, if you're going to do the trapezoid, you're going to need a few things on it. We'll get there. Okay, so let's figure out all the areas first and then go from there. Okay, so let's focus on this triangle first. Let's look at shape A. The triangle first. Now, when you guys are doing the triangle, the formula for triangle is 1/2 times base times height, right? So we need to know what the base is, and that's going to be that number right there. And that is not totally obvious right now. That is something that is not given, and you're going to have to do a little bit of problem solving to figure that out. This is not necessarily shown that this is a right angle right there, but I can kind of assume that that is a right triangle. And we have the height at least. We know the height is 6. So here, let's focus on this base part that is not obvious. Like Like I said, we're not sure what that is. Okay, so we're going to have to look around the shape a little bit. Now I'm going to go ahead and kind of erase some of the marks I made just so that we can see it better. But this is where, again, it's going to be to your benefit to write all this stuff out. Print these pages out or draw the pictures out as best you can. But sometimes just looking at it and trying to figure it out in your head is not the best strategy. You're going to want to write these out. Like I said, we're looking for this segment right there. All right, well, we know that from here to here, we know that that is 6. And then we're looking for that right there. Now what I'm going to do, my eyes are instantly drawn down to this number right here, because that number 15 represents the distance from here, and then this doesn't go all the way, but it goes from there to there. So you can safely say that it's 15 from here to here, right? It's 15 units. Now this is not given, it doesn't say inches, it doesn't say centimeters, it doesn't say anything, it doesn't say feet. So we're just going to call it units since we don't have a unit. So if that's ever not given, just use the generic term units. All right, so like I said, we know that it's 15 units from this point right here to this point right here. And we know that is 6 units. It's 6 units from there to there. So 6 plus what is 15? And then you can put a 9 right there, because 6 plus 9 is 15. So that tells you that the base is 9. Now we have all the necessary parts that we can use to figure out the area. So we're going to do 1/2 times 9 times 6, and that's going to be the area of that triangle, of shape A at least. And so for shape A, I'm going to do 1/2 times 6 times 9 just to make it easy. 1/2 times 6 is 3, and then 3 times 9 is 27. And I'm just going to put U for units, so 27 square units. So it definitely helps to label stuff, write stuff down, keep an organized list, keep your information handy. And like I said, if you try to commit all this in your head and to do it all mentally, it's going to be a little bit tough, I would say. The next shape I said that I kind of saw here. Now, again, you might be looking at this on your paper or on your computer, wherever you're looking at it, and going, I see something totally different. And that's okay. Like I said, if you arrive at the same answer as me, it doesn't matter. It doesn't make me more right, doesn't make you more right. I do agree, though, that sometimes there is an easier way. If people can make a good case for that, like, hey, I found a definite easier way to do this, yeah, go ahead and show me. So, and I'm not saying what I'm doing right now is the easiest way either, by no means. All right, so for this shape right here, we need to figure out the length from here to here. Well, that's pretty easy. We've already decided that's 15. And we need to figure out the height. So is the height 9? Because sometimes we accidentally do that. We might look at this number right here and go, oh yeah, that's 9 for sure. But no, 9 is the distance from here to here. We're looking at the distance from that point to that point. So that's not 9, not at all. So if you just move your eyes just a little bit to the right, you'll notice there's a 6 right here. So that's also 6. So I know you didn't really have to put a 6 here. Some people were just like, I knew it was 6 right away. But I'm just making sure, I'm just kind of going through some of the common mistakes that people make with this. And so for that particular shape, we're going to do 15 times 6, and that'll be the area of the rectangle that's kind of in the middle of that shape. So 15 times 6 is 90. So I'm going to put 90 square units for that. Now we're left with the trapezoid at the very bottom. Now our previous lesson focused on the trapezoid, which told us that the area of a trapezoid, and I totally don't expect you guys to commit this to memory, but the area of a trapezoid is going to be 1/2 times the height times, and then remember, parentheses, base 1 plus base 2. And the bases, remember the bases are the parallel parts of the trapezoid. So the base right here, you can call this base 1 or base 2, it doesn't really matter. But that base, we're going to call that base 1, that's going to be 15. And right here, base 2, what is it from here to here? That's what we're talking about right there. And I see 15 as well right here. But remember, that 15, look at what that represents. That's 15 from here to here. So what is that going to be? Well, we know that that is 15 from here to here. So if that's 15 and we know that this is 6, we'll just take that away. Take that away. So what's 15 minus 6? That's going to be 9. So that's going to be 15 and 9 right there. All right, and we're left with just one more section here, and we need to figure out the height. So the height, remember, is the shortest distance between one base to the other. So this is going to be the height right there. So we need to, and remember, don't guess when you do these. Don't just look at that and go, hey, you know what, that looks like 2. It looks like 5 units. It looks like 6 or half of 9. It's not about guessing. It's about using the information that you see in front of you and then kind of making deductions and just kind of problem solving and using good reasoning as to what that number is. Okay, so here's what we do know. We do know that from here to here, it's 9. So that's what we do know. All right, so from here, just kind of looking at the other side, from here to here, that's 9. All right, but look, from here to here, it's 6. It says 6. So if that's 6, and we know that it's 9 all the way, well, that makes the height 3, because 3 plus 6 is 9. So there's the third number that is going to be important. So now let's fill it all in. So the base 1 is 15, base 2 was 9, and the height was 3. So now we have all the important figures that we need to figure out the area of the trapezoid. So we're going to do 1/2 times the height. Now the height is 3. The bases are 15 plus 9. And then I'm going to use order of operations here to solve that. These come first. So you're going to do 1/2 times 3 times 24. Then I'm going to do, instead of 3, I'm going to do 24 times 3. Now 1/2 times 24 is 12, and 12 times 3 is 36. Okay, so let's recap what we just did here. So the triangle was 27 square units. The rectangle, which I ended up erasing because I was doing a lot of work here, the rectangle ended up being 15 times 6, which is 90 square units. And the trapezoid, which we just finished, was 36 square units. And now it's just a matter of you adding all that up. So 27 plus 90 plus 36. All right, now that we're all through with this problem, you should have ended up with 153 square units. And then again, if you see this differently than I did, you may or may not want to do it this way, but it's kind of up to you. There might be some people that are looking at this and maybe they saw this. And I think putting that trapezoid in there made it a little bit more tough. But maybe you see a complete rectangle right here. You see a complete rectangle, and then like what I was saying before, someone came along and cut out a triangle, They cut it out. So that's like a negative space right there. That's a negative area. And so that is an area that you're going to subtract from the total area. So if you want to, you can figure that out. Okay, well, the complete rectangle, this whole thing, if that triangle wasn't taken out, well, that would be 9 times 15, which is 135 square units. Now that's including the triangle in there and everything. Next, what you can do is we can figure out the area of this triangle right here. Now that triangle right here, this height that is not given, I can surmise that is 3. And the reason I can say that is 3 is because from here to here is 6. So if that's 6, and this is 3. Well, 6 plus 3 is 9, and that's what it says over here. All right, so then we're going to do the area of a triangle, which is 1/2 times 6 times 3, which is going to be, well, 1/2 times 6 is 3, and 3 times 3 is 9 square units. So we can take away the 9 from that, and what do you get? You get 126 square units. Now, we're not through with this problem. I have one more shape that we have not figured out the area of, and that's this triangle that's right here at the top. We kind of remember what we did last time. We had to figure out that base part right there, and then that base part was 9, because 6 plus 9 is what? 6 plus 9 is 15, because we know that from here to here is 15 units. So now we're just going to do the area of a triangle, which is 1/2 times, I'm going to do 1/2 times 6 times 9 instead of 9 times 6. 1/2 times 6 is 3, and 3 times 9 is 27. So that's 27 square units right there. And then put that together. You do 126 plus 27. And guess what you get? You get 153 square units. And that's exactly what we got before. And actually, I think the way I just did it there was much easier than what we did before. I think it was much easier to kind of leave off that trapezoid if you wanted to. Okay, for number 3, what does it look like you have here? And again, you could look at this a couple different ways. What jumps out at me is I see, for this particular shape, is I see a triangle that is all on top of a rectangle. So we have a triangle, and this rectangle is from here to here, that's 10. So that's easy to figure out the area. That's going to be 50. And again, we're not given any inches or feet or meters or anything like that. So I'm just going to put 50 square units. All right, that was the easy part. And the more challenging part is going to be figuring out the area of this triangle. Now that number right there, what is that length right there? Well, there's nothing there. Did we just guess? No, we have to look around, scan around the shape and just kind of look and see, well, that's 5. Well, this has to be 5 as well. So that's going to be 5. All right, now when you find the area of a triangle, remember that's 1/2 times the base times height. That's the formula. It's going to be a good idea to have these formulas kind of in front of you too when you're working on these problems. You know, for me, they come right to me. I know these off the top of my head pretty well. For other people, especially if you're a novice at this, you're going to want to have these in front of you. So the area of a triangle is 1/2 base times height. Now, well, we need the height. So the height is going to be from here to here. That is not the height. Remember, because that goes down at an angle. We want it to be at a right angle to the base. We want it to be at a right angle relationship to the base. So we need to figure out that number right there. And again, are we going to guess? Are we just going to go, well, it looks like it's maybe 3 units or it's 5? No, this is not a guessing game. We have enough information on this page to figure it out. And here are the 2 numbers that are going to help you figure it out. Well, the overall height of this figure, it says it's 18. That's 18. That's from the very top of that shape to the very bottom of it. That's 18. Well, we're also given that the rectangular part of the shape from here to here, that's 10. So if that's 10 from here to here and it's 18 total, well, 10 plus 8 is going to be 18. So that has to be 8 units. See, that's 8, and that's 10, and 10 plus 8 is 18. So now we have enough information to figure all this out, so we're just going to do the formula. 1/2 is always what it is, that's because that's part of the formula. 1/2 times base times height. Now I'm going to do height times base because that's easier. So 8 times 5. And remember, multiplication, the order of which you do the multiplication does not matter one bit. So you got 1/2 times 8, which is 4. And then you got 4 times 5, which is 20. So the triangular part of that shape is 20. And now we have enough information. So the rectangular part was 50 square units. The triangular part was 20 square units. Put it all together, what do you get? You get 70 square units for the area. Don't forget to do that. I think that's a lot of times when people do the area of these shapes, they forget to kind of put them together. Like, what do I do with all these numbers? Well, you're going to add them up, right? We figured out the area of the triangle was right here, right? And then we had to add that to the area of the rectangle, right there. All right, I'll stop there with number 3. I mean, there's another way we could do it. If you know another way, which maybe you can read my mind right now and tell me what I'm thinking, what other way or what other shapes do you see? Maybe you can put that in the comments or something. Let's kind of move on from here. We don't have to go over all like 15 ways to do every problem. Let's go into number 4. All right, for number 4, what do you see here? All right, what do we see? And again, you might see this totally, completely different than the way I'm seeing it. But obviously, you see a triangle here, kind of a more narrow rectangle right there, which is just a parallelogram. And that's base times height. And then you might also see a parallelogram, and that's also base times height. All right, let's start with that parallelogram, because I think the parallelogram is one of the tougher ones to figure out. Now, here's the thing. If that's 9, so is this. I'm talking about from here to here. That's 9 units. All right, now we need to figure out what the height is of that shape. Now, this right here is not the height, because look where that, if you look at this segment right here, where it meets the base, well, that's not, is that a right angle right there? Not at all. That's not a right angle. So we need to figure out the perpendicular distance, or the shortest distance from one base to another. So that is going to be the height. And this is where, like, I think these problems are a little bit more challenging, a little bit more interesting. But that's where you guys have to kind of use a little bit of problem solving. Okay, and here's what we know. We know that this entire length of that shape, this is a total, this is a composite figure, but from here to here, it is stated in the problem that that's 16 units. All right, so let's break this up. All right, from here to here, I'm going to draw this kind of terribly, but from here to here, that is 7 units. From here to here, what is that? That's 3 units. Just put 3U. And then from here to here, that's the part that isn't totally obvious. All right, so let's look at what we have so far. We have 7 and we have 3. Well, what does that make? That makes 10. That makes 10. Well, we know that from here to here, that's 10 units. 7 plus 3 is 10. What does that have to be? Well, we know that the entire thing is 16. So if that's 10, this has to. It must be 6. 6 plus 10 is 16. So the height we just figured out is 16 units. So the height is definitely 6 units. Okay, so let's figure out the area of that parallelogram. So the parallelogram is going to be base times height, which is going to be 9 times 6, which is 54 square units for the area of that part right there. And like I said, I think figuring out the area of this shape right here, so figuring out the area of that parallelogram, I think, was probably the toughest part. So sometimes it's good to put the toughest part at the beginning, or sometimes put it at the end, doesn't really matter. All right, now we have a kind of a tall, narrow rectangle that's in the middle there. And we know that that is 3, so that's also 3. And now we just need the height of it. Well, we have the number right here, that's 9. So that's 3 times 9, which is going to be what? That's going to be 27 square units. And we don't have to do half of that or anything, because it's not a triangle, it's not a trapezoid, it's just a rectangle, which is a parallelogram. So 27 square units. We're left with the triangle. Now the triangle, that part right there, I'm going to call that the base. From here to here, I know, like, remember what I said in a previous lesson. Does base mean bottom? Not necessarily, no. But that is the base because there's a height, respectively, that goes along with it. And this right here, that number right there is the height. And what did I tell you about height? What do you look for height? Now, I've kind of drawn all over this page, but remember, look for that right angle. Look for perpendicular segments for right there. There to there, that's a right angle. So that's got to be the true height of that triangle. So the height of it is 7. So now we just have all the information that we need to figure this out. So the area of a triangle is 1/2 times base times height. Now 1/2 times 9 is 4.5. And then you're going to do 4.5 times 7. So 4.5 times 7, and this is where, you're allowed to use your calculators. I know if some of you are sitting at home and your parents are there watching you do this, if they hear me, they're hearing me say it's okay to use your calculator. This is where it's all right to use your calculator because it doesn't matter how good you are with the calculator. You better know what to do with it. So I ended up getting 31.5 square units for that. Okay, so that triangle right there was 31. So now let's put it all together. So we've got 54 for the parallelogram. We've got 27 for the rectangle that was in the middle. And then we got 31.5 for the triangle. So we're going to add all that up. Put all this up. Now I'm not going to use a calculator. I'm going to actually do this the other way. So we got 5 here. Drop down that decimal point right there. 4 plus 7 plus 1, that is 12. Put the 2, carry the 1. 1 plus 5 is 6. 6 plus 2 is 8. And then 8 plus 3 is 11. And there's your area for the complete figure, which is going to be 112.5 square units. And that does it for that shape. Okay, so I hope everyone got this. I know these look kind of complicated, and they are if you try to do it all in your head. But if you break it up, split it up into smaller pieces and different shapes, it's going to make this a lot easier. And also having your formulas on hand is going to help you quite a bit. All right, everybody, have a great day. See you later.